Greetings, programs. This video is about the second inferential test that I'm going to teach you. I think we already went through cross-tabulation and chi-square. This test is called correlation, and as you see by the nice two lines up here, correlation tests whether really two variables, but you can put more into a matrix. Whether two variables show a direct or indirect relationship to each other. In SOS 360, you will only be responsible for bivariate correlation analysis. Bivariate means two variables. If you happen to go to grad school at San Marcos, you take the MASP program in sociology, you'll learn the next step up from correlation, which is regression modeling. That's where the big bucks is. Okay, but here we're going to learn about correlation because it'll give you a good intro to regression. Okay, so I'm going to blip to another Word document and then we'll come back to how to run it. I have this also in the class this week. It's just a lot of information about correlation. I think correlation is probably the most confusing test of the four that I'm going to teach you. And the first thing you have to remember is that nominal variables cannot be used in a correlation. You must use ordinal and or interval level variables, with answer lists that can be ranked, like ordinal, very unhappy to very happy, or interval, how old are you? 1925, 26, or 62 years old, right? I guess I made this last year. A correlation coefficient, like this, shows two things, the strength and direction of a relationship between two variables. Okay, so let's talk about strength. We're going to use this same coefficient, 0.337. The coefficient is a proportion number, right? When you were doing, well, maybe you weren't, but if you had me for 201 and you remember the probability lesson, you ended up with proportions. So this is what a proportion is, a decimal point and three numbers to the right of it. So these coefficients lie somewhere between 0 and 1 for a positive correlation and 0 and -1 for a negative correlation. Coefficients closer to 0 are weaker. Coefficients closer to 1 or -1 are stronger. A perfect correlation of 1.000 only occurs when a variable is correlated with itself. And you're going to see that with every correlation test that you run. And I'll show you that in a little bit. Here is a nice little diagram about, how to read the coefficients in a correlation matrix. You can have weak to moderate, moderate to strong, and, anything above 501 or 500 is a strong correlation. So, negative correlations are pretty much the same thing, but they all have negative signs in front of them. 0.001 to 0.200, what is that? Yeah, right? That's a weak correlation. 201 to 300, weak to moderate, and on and on and on and on. This is something that's important, right? Negative 0.389 or positive 211, which is the stronger correlation. The answer is negative 0.389 because it is closer to -1. It doesn't matter whether it's negative or positive. Whatever the number is that's closer to 1 or easily the higher number is going to be the stronger correlation. You know, what screws you up is you have a negative sign and, you know, a negative and a positive, and you think that 0.211 is stronger, but it's not. It's the one that's closer to 1 either way. Okay, so that's strength. Now we're going to talk about direction. If a coefficient has a negative sign, it means it is an indirect negative relationship between the two variables, right? So as one variable increases, the other one decreases, or vice versa. One variable decreases, the other increases. For example, the more hours you spend watching TV per day, or, you know, hell, it's not even anymore. Now it's your cell phone or your pad or your laptop or whatever, the less hours you're able to spend studying. Okay? One TV goes up, studying goes down. If a coefficient has a positive sign, there's a direct or positive relationship. As one variable increases, the other also increases. Or vice versa, if one variable increases, the other decreases. For example, the more gas you put in your car, the more miles you'll be able to drive. There are 3 numbers in each correlation cell. You'll see that in a minute. The first is the coefficient, you know, like negative 0.414. The second number shows whether the test is significant or not, like 0.001, for example. Remember that the number for significance in any of these 4 tests must be less than 0.05 in order for the test to be significant. Okay, so if this was your number for significance in the cell, that would be a significant test. The third number in the cell is the n, or the total number of cases in the relationship, you know, like 1426 out of 1500. You can just ignore this number, right? Why do more work if you don't have to? You're only interested in the coefficient and the number for significance. Okay, so this document is in this week. You can look at it at your leisure. The other one that's in this week is the correlation instructions, which I showed you just for a second. And it's much like all the other instruction sheets for the inferential test. So if you want to run a bivariate correlation from the menu bar in SPSS, you go to Analyze, down to Correlate, and over to Bivariate. And then a little window pops up, and this one's different, right? Remember in crosstabs, you had a row and a column box. Here in correlation, you only have one box, and you just throw all the variables you want in there, right? So select and move 2 or more variables into the variables box. You know, the example that I'm going to do is we're going to put age and income 91 and education and TV hours into our correlation analysis. Right below the variable list, I guess, there's different coefficients that you can ask for. And by default, Pearson is clicked. But if any of your variables in your correlation are ordinal, right? Remember what ordinal are. You can tell, you can tell that the answer list is ranked or ordered, but you cannot tell the exact difference between any 2 variables. Like in the case of, any 2 answers. In income 91, you know, the answers are in ranges. Pull that thing up real fast. You know, here's income 91. Wow, that is a big variable. But look at all these answers. They're all in ranges. So immediately, if you see a variable that has answer choices in ranges, that is automatically ordinal. Because, you know, if my income is $27,000 a year, then whoever's talking to me on the phone is going to type a 15, because that's the value for. Oh, get out of there, would you? I love computers. 15 is the value for this range, 25 to just under 30. And you can't know that my exact income is 27,000. Okay? So, if any of your variables are ordinal, like income 91, which is what we're going to put in our little demonstration, I want you to unclick Pearson in the coefficient box and click Spearman. If all of your variables are interval level, like age and number of years of education and TV hours, because those answers are just like 19, 20, 21, and you can tell the difference. You know, how many hours a day do you watch TV? Well, I watch 2 hours a day or 20 hours a day. You know the exact difference. Okay? Do not click the options button. Once you have your variables in the box and you have clicked the appropriate coefficient, just click OK. And then the matrix pops up, right? Let me see if I can do this correctly. What is the matrix? The matrix is all around you. What a great movie that is. If you haven't seen the first Matrix, watch it. Here is an example of a correlation matrix. This is with only two variables, right? Bluegrass music and country western music. And we're trying to find out if there's a relationship between these two variables. So let's see, Spearman's row. Remember, we clicked Spearman. So Spearman's row, which is right here, gives the strength and direction of the relationship. Now look, remember what I said, you're going to see perfect correlations in every matrix that you run. So here's bluegrass music on the row, and here's bluegrass music on the column. This is the intersection of those two variables. And of course, you're going to get a perfect correlation of 1. But what you want to look at is bluegrass music and country western music. Well, actually, let's do it down here. Country western and bluegrass. And I have that cell outlined in red. So the coefficient for this relationship is positive 0.413. Okay, so there's a positive direct relationship to this. So as your fondness for country western music goes up, it also goes up for bluegrass music. The next number, 0.000, is the number for significance, and that is definitely less than 0.05. So this particular correlation, bluegrass and country western music, is a significant test, right? And remember what that means. If you have a significant test, you can make the jump from the sample that you're looking at to the greater population that you're talking about in your report, like the city of San Marcos. Okay, so you have a moderate to strong, or maybe, no. Yeah. Moderate or a moderate to strong coefficient in 0.413, and the significance number is definitely less than 0.05. Okay, so those are the two questions that you have to answer when you look at a matrix like this. And forget about this. What is the coding direction of the variables? Is it direct or reverse? I'm just not going to teach you that. Okay, it's important, but when we get back to school and we're all staring at each other in a classroom, you know, then I'll talk about it. Okay, so, but right now we're going to run this correlation. We're going to put these 4 variables in a correlation. So I'm going to go to SPSS and our favorite little database, the GSS 93, and I'm going to go to Analyze and Correlate and Bivariate. Look right below correlate, it says regression. So that's how close these two things are. But I'm going to click Analyze, Correlate, and Bivariate. And this little window comes up. And like with all windows in SPSS, for the most part, the left side has the variable list. The right side is blank. This is where you're going to move your variables over to. And here, right underneath that, is the correlation coefficients. Okay, so what did I say? I'm going to take, what did I say? Age, income 91, education, and TV hours. All right. So age and education and income, is that what I said? Yeah, income 91 and TV hours. Okay? Now, since income 91 is ordinal, I'm going to unclick Pearson and click Spearman. And then I'm done. You don't have to worry about two-tailed or one-tailed. Leave this clicked. Once you move the variables in and select the appropriate coefficient, just click OK. And I'm going to do it again real fast just so we can have it right where we can see it. Here's the matrix, right? Remember the matrix. If you take the red pill, okay, forget that. But here's how it sets it up. All the variables are on the columns and all the variables are, all the variables are in the row and all the variables are in the column. That's how you get the intersection between, two variables. And look at this. Here's a perfect diagonal line of perfect correlations. What I meant to say was a diagonal line of perfect correlations. Remember, these are all, anytime you see 1.000, that is a variable correlated with itself. So here's age and here's age. There's the intersection. Okay, we don't care about those. What we really care about, and we talked about it before, is, let's see, kind of, the hours per day watching TV correlated with the highest year of school completed, right? Here's the little cell that has the coefficient and the significance number. So what does that say, right? If you want to look at the relationship between hours per day watching TV and the highest year of school completed, here's the coefficient. It's negative 0.330, right? Remember what a negative means. As one variable increases, the other variable decreases. So what that's saying is that the more hours per day you spend watching TV, the less, the lower number of years you're going to have completed in school, right? That's what that negative sign means. And it's kind of a weak to moderate relationship, certainly enough to report. And the number right underneath it is 0.000. So here we have a negative relationship between these two variables, and it is a significant test. Let's look at another one. How about highest year of school completed and total family income? So I'm going to start here on the row of highest year of school and go right over to total family income in the column. And this is what I have, this little cell. So the coefficient is a positive 431. That tells you that as the number of years of school completed goes up, Total family income also goes up, right? Which is kind of like common sense, right? A lot of statistical analysis is really things that you could think about and go, well, you know, that probably has a positive relationship. But when you run the analysis, then you have numerical data to back up your common sense, right? I can't remember the exact word for it, but maybe I will by December. No, I'll try. So, positive relationship, weak to moderate, or maybe moderate, between highest year of school and total family income. Also, the significance number is 0.000. That is a significant test. Okay? Let us run one more real quickly, and then we'll be out of this video. So I could go back to analyze and correlate and bivariate, but why should I waste all that time? I can go here to the magic button with the green arrow pointing straight down and click it, and look what's right there. Bivariate correlations. Okay, so I'm just going to click reset and start over from scratch. So let's see, what do I want to look at? I don't know. How about, no. We already did that. And we did that. Well, there's nothing left to do, damn it. How about, get something that you can relate to here. Oh, opera music. I know you all go to operas all the time. Let's get Pill-OK. I think we looked at that before. Opera music is how much you like opera music. Pill-OK is, do you think the pill should be given to high school girls? And what are we going to put with that? Let's put this one with it. Poll views. Okay. Opera is ordinal. Poll views is ordinal. So I'm going to unclick Pearson and click Spearman and click OK. And then I'm going to run it again just to put the table in a good place. So here we are, right? Remember, we have the totally useless diagonal line of perfect correlations. We don't have to worry about that. Let's look at think of self as liberal or conservative and birth control to teenagers. Now, that has a weak to moderate positive correlation of 0.240. And it is a significant test. But I want to take a look at this variable, right, in the variable list button, because we need to talk about that for a second. So poll views, let's make this not so gigantic. Poll views is, you know, are you liberal or conservative? And you could make a case that this is a nominal level variable, but because it starts with extremely liberal and goes all the way to extremely conservative, I'm going to make the case that it is ordinal. So extremely liberal is 1, extremely conservative is 7. So the higher up you go, the more conservative you are. So this is saying that there's a positive relationship between thinking self as liberal or conservative, and whether or not you favor giving birth control to teenagers. And that's a really shitty example, so let's just forget about it. Okay, let's try another correlation. That makes sense. We'll do a real easy one. Let's take age wed, which is how old were you the first time you got married, and spanking, right? No, not spanking. Let's do TV hours again. Let's make it easy. And we're only going to do 2 of these. So I think both of these are interval level variables. So we can leave Pearson clicked. I'll do it again. And here's a real easy table to read. All you have is 2 variables. So all you're going to look at is how old were you the first time you got married? The relationship between that and hours per day watching. Okay? It's a negative, really weak relationship. 0.030 is so close to 0 that it's almost non-existent, but we'll give it a week. So that's saying that as the age, your age when you were first married goes up, the number of hours per day watching TV goes down. And look at the significance number, 0.301. That is not less than 0.05. So this is not a significant test. And all you would have to tell me if you're going to do a correlation and write it up is that, you know, we ran a correlation test between these 2 variables. There's a weak negative relationship, and it is not a significant test at the 0.05 level. Excuse me. Okay, so that was like a really lengthy explanation of what correlation is and what how to run a correlation, and then we actually ran a couple tests. Okay, so I think that's the best I can do. Come into the office hours if you have a question and you want to run correlation, or send me an email. And I think that's that. See you in the next video. Bada bing, bada boom.